All right, I think we're going to get started. Thank you all for coming out. The last talk, is it the last talk of the day? It is for me. How many of you are here at KubeCon for the first time? If you could raise your hand just to get, wow, okay, awesome, welcome. This is my fourth KubeCon, and if you remember, the first one was actually about Kubernetes. And since then, we've started to see the ecosystem of tools that layer on top of Kubernetes and around Kubernetes start to flourish in the CNCF. And we got all these new technologies. And this talk today is going to be about a couple of technologies related to service mesh and service proxy and that kind of stuff, but also how it ties in with the applications. And I'm going to hopefully, this isn't going to be a deep dive on any of these topics really, because there's just not enough time. But hopefully you'll walk away understanding how the application languages that you might use to build your services interact with or where they fit in an architecture with technology like service mesh. Again, show of hands, how many people have heard of service mesh? Okay, awesome, a good room. Now, how many people are actually using service mesh? Wow, okay, awesome. Okay, so let's get started. First of all, my name is Posta. I'm a chief architect at Red Hat. I work with our customers in mostly North America to build distributed systems on top of cloud-native platforms like Kubernetes or the Red Hat distribution of Kubernetes OpenShift. I spent some time at large enterprise companies like banks and retailers, but I did have the opportunity to spend some time with Zappos.com and with Amazon about 5 years ago, before the whole microservice DevOps thing blew up. And what I try to do is help our enterprise customers know and understand what it means to do DevOps microservices and be successful and achieve their outcomes, not just adopt new technology for the sake of adopting new technology. I try to work in the open source communities when I have time. I've been in the past contributor to communities that are involved in integration, enterprise integration, things like Apache ActiveMQ, things like Apache Camel, and more recently in a project called Istio. So I've written a couple books on microservices. I wrote the first book on Istio. And if you struggle like I do in finding the right gift for your loved ones for Christmas, may I recommend getting multiple copies of Istio in action. That's the book that I'm working on right now. I'm hoping it's going to be an in-depth treatment of what Istio is, how to be successful with it, when and when not to use service mesh, and so on. So it's in early access, so if you go check it out right now, there's only 4 chapters there, but I'm at times working on it, and so hopefully get it done. So let's jump into it. Our industry is talking about innovation constantly with how it relates to technology. At one point, your enterprise companies that you work for were disruptive, and they were the new person on the block, and they were innovating and finding ways to provide value to their customer. And then they grew, and they grew, and at some point they used technology to help streamline their business, save money on operations, and they ended up with a complex set of systems over various years, different vintages of technology, from mainframes to client-server technology to the SOA days, and now we're talking about a new generation of technology, right? But what's interesting about right now is that the technology we're talking about ideally will help these enterprises help people build things faster and get things out to production faster so that they can test and validate whether or not the ideas they have that would generate value actually do generate value. Sometimes they don't, but the faster you get it out there and test, the quicker you'll know. So we're in this world where we need to build that engine to be able to cheaply do deployments and the automation and the infrastructure in place to safely do that. But we can't neglect the technology that we built in the past, which helped our companies get to where they are today. A lot of times these, if we call them legacy systems, are generating billions and billions of dollars, right? So we can't just ignore them or wish them away. So in some way, we have to work between the newer technologies and the older technologies to get things out to customers, and that gets very complicated. It's very hard to change some of the older systems, whereas on the new side, we're trying to go even faster. But as we start to adopt microservices, serverless, all these new architectures for building applications, we realized something pretty quickly that we didn't have to deal with as much in the older paradigm. And that is that as we move to a services-style architecture, we move and push complexity that was otherwise hidden from us or assumed away in between the services. And now we have to face that head on. We can't ignore that. Take a relatively simple example where customers are trying to check out on your website and they're adding things into their cart. And a simple click on their website might generate a bunch of different calls to backend services, to legacy services, and the application developer has to figure out how to do that successfully. Because if you look at this diagram, so many things can go wrong. So many different points of failure here, both in obviously the network hops, but when you start making calls out to services, now you have to deal with data transformations. Now you have to deal with splitting messages, calling services that might update data on their end, and deal with duplicates and all these weird partial failure scenarios that could throw a wrench into the whole system. So the types of problems that we have to solve here involve getting these services, getting these back-end older systems integrated in a way that they can deliver value. Some of the problems I touched on include orchestrating the calls of services to a bunch of different backends. Right, call this one, then we call this one. Some of them can go in parallel. The integration developer needs to be able to do this. Aggregate and combine and transform messages, deal with errors and unexpected results. When you get errors, do you fall back to some pre-computed value? Do you try again? What happens in those scenarios? Those are things that application developers have to think through. Problems, especially coming up when you've come from a system where you've built on a nice ACID database and atomicity is taken care of for you, concurrency is taken care of for you. Now you go to this world where none of that's taken care of for you, but you have to figure it out somehow. And you're probably not going to use distributed transactions, so you're going to develop some kind of saga pattern or compensation strategy to deal with, well, when I make a call to two services and the third one fails, now what do? I might have to go back and undo some of those changes that I made. So we need to take this into account. We need to build APIs around our existing our older legacy services, so it's easier for the newer clients, the newer applications, the newer services to interact with them. And of course, last but not least, we have to deal with actually making calls over the network. Because if you've been to probably any of the talks at this conference, you know the network's not reliable. The fallacies of distributed computing hold here. So the problems that we have to solve in that space, especially on a cloud platform like a Kubernetes or a public cloud infrastructure, we have to solve for things like service discovery and timeouts and retries, circuit breaking, all of these different patterns, just because we're talking over the network, and it's not necessarily something that we did as much in the past, certainly not on these unreliable infrastructures like cloud platforms. So at the end of the day, when you start to build a system that has to talk to a bunch of other services, and you have to solve these different integration problems and communications problems, it ends up being the responsibility of the application developer to solve for the correctness and safety of the requirements that they're trying to implement. You can't offload this to some infrastructure. I don't know, this might be a little obscure, but there's a paper out there called the end-to-end argument that talks about how there's so many different hops in the system and things can go wrong, where just because you optimize a communication channel doesn't mean the system automatically gets implemented correctly. So the applications have to take that into account. In the past, we tried to kind of centralize that problem solving. We tried to centralize how we dealt with and implemented this complex and tricky integration stuff. We try to say, well, we'll put this product here in the middle of our architecture, and this team over here will be responsible for implementing transformation, content-based routing, protocol adaptation, service discovery, load balancing, all that stuff, right? So we said, we'll put that over here. We won't change any of our systems. We won't change any of our protocols. We'll just insert this thing in the middle of our architecture. And the problem with that is it's not built for speed. It's not built for being able to make changes fast, right? When we adopt cloud and DevOps and Microservices, all this stuff is about getting changes out to production faster and learning. And with the older generation of technologies, when it came to integration, the approach we took might have worked for some, and we have customers where it worked well, but in today's environment, it's not something that will allow you to keep pace with the amount of change that you want. So what we want to start looking at this problem through the lens of is integration isn't a silo, isn't something you can just offload to someone else. Integration is actually part of building your applications. So what we would like to do is enable application developers to correctly and consistently build integrations with backend systems through APIs or messaging or other means in their applications. And there's various ways to do this, right? Everyone has their favorite language. Everyone has maybe their favorite framework on top of a language. And there's many ways to do this. But I would like to introduce you to a particular approach from the good folks at WSO2 who started a programming language, a new programming language, specifically aimed at solving this problem, this integration as part of application development problem, by focusing on constructs in the language that make it a lot easier and straightforward for developers to stand up new APIs, implement services that interact with others over the network, make those calls resilient, and implement the patterns that you might need as first-class citizens, not afterthoughts or additions or frameworks to an existing language, built into the language. Another interesting part about, or fact about Ballerina is that it's implemented with a particular mental model up front. So typically when we try to reason about applications that have various forms of concurrency and network calls and so on, sometimes it's very difficult to reason about them, especially at runtime, but even when you're looking at the code. And the folks at Ballerina said, well, when you try to explain those interactions to another developer, you would typically go and draw different diagrams. Sequence diagrams tend to be very popular when trying to describe concurrent behavior. So they said, well, why don't we make sequence diagrams the foundation of the language, so that when you draw it on the whiteboard, it's reflected the same way in the source code. And we'll build this as a service-first language. And so that's what they did. When you write, I mean, it's a full-blown programming language, statically typed. You start writing code in it. You can automatically get the sequence diagram that shows all the various interactions. And actually, here's let me show you an example. Here's a very simple, very straightforward example where we're declaring a service. We don't have a main and bootstrapping all this other stuff just to be able to build an HTTP service. It's baked in, and this is a language construct that says we want a service. Here's the endpoint, and we want to listen on this particular port. And there's patterns for doing things like interacting with legacy systems, interacting with other services and databases and message queues, for doing transactions. Security is built in as a first-class citizen. So you can do things like track the state changes of a particular variable through its life cycle to see, are we passing this variable to a SQL engine? And is this unchecked by the client? I mean, the clients are just passing in random code. Could we end up with a SQL injection? So there's built-in security in terms of provenance of data in the language. And like I said, you can get sequence diagrams automatically. This is obviously a very simple one. This is a reflection of the previous code listing. But when things start to get more complicated and you need to understand and socialize, importantly, socialize with the rest of your team, what it is that you're building, then these diagrams become very, very helpful. Now, what about, so that's all good for, we can solve things like orchestration, we can solve things like concurrency, security in the application, transactions and compensation, that kind of stuff. We can solve that kind of stuff. Ballerina also does things like we would expect from a microservices framework, like circuit breaking and bulkheading and timeouts and retries and that kind of thing. So what about that application networking stuff? A little bit lower level, but it's still very, very important. So what about all that stuff? Service discovery, timeouts, retries, circuit breaking, rate limiting, metrics collection, distributed tracing. These are not optional things. Languages, whether Ballerina or anything else, typically have some support for these types of patterns. Now, Netflix helped kind of jumpstart, at least the Java community initially, by calling these things, they started talking about microservices, build up a nice, wonderful story about that, and then offering to share their code, which is awesome. Netflix is awesome for doing that. And all these distributed systems things that we needed to solve were effectively called microservices patterns. So they open sourced their libraries that solved some of these problems and brought a consistent way of implementing application networking to the applications. Now, and in a cloud environment, in a cloud world, that's good. Basically what you're doing is you're co-locating application business logic, application integration, and now the application network stuff into the application. It is the responsibility, like we said earlier, it is the responsibility of the application to do that. And it made it easier to scale and deploy into VMs and containers and so on. But that was Java specific. That was very language specific. And as our customers in the enterprise started to adopt container platforms and new technology, one of the overarching goals or benefits to doing a services architecture is, well, you can, don't get too crazy with this, but you can pick the right technology for the service that you're building. So what if you're using Node.js? Very popular language. You might go onto Google and go onto NPM and try to find, well, what's the Hystrix circuit breaker equivalent in Node.js? Or if you're, I don't want to use that stuff, I want to use Go, you still have to go out and find, again, for that language, and any framework that you might use in Go, the same thing. For Go, for Python, for any language, including languages that you might think aren't in use today. And they are, they very much are. At least back when I was working at Zappos, so again, 5 years ago, hopefully some of this has been pulled out, but Zappos was written front end, back end, subsidiary websites, everything on Bash and Perl and MySQL. And some of that code, you're still going to see laying around in your enterprises. But we still need to solve those application networking problems. For each of these languages, if we decide to go the application language route and find an implementation of circuit breaker, find an implementation of load balancing, of distributed tracing, of rate limiting, and on and on and on and on, we end up with a combination, a large combination of these libraries for each of these different languages that we might use. And the important bit about that is now you have to maintain it. You put that into production, you have to fix bugs in it, kind of work around all of the slight differences in implementation for each one of the languages. And that becomes very expensive. That becomes very difficult to scale your operations. So what we'd like to do is make operability of our services, once we get that into Kubernetes or whatever, a top priority. We want to optimize our ability to operate our services at scale. And so that's where the app networking versus app integration part comes into play. We have things like regular programming languages, Spring, Apache Camel, this type of stuff, or purpose-built languages like Ballerina at the application layer. But now we need to solve in a consistent way for app networking. And that's where technology like Envoy comes into play. So Envoy just recently graduated to the top level of the CNCF. The keynotes was featured. And Envoy is a service proxy that consistently solves the application networking parts of this set of problems for any application and any framework on any language. Because the way it's deployed is as a service proxy. And that's, I'll stress that again, it's a service proxy. That's not necessarily intended to replace your API gateways and HA proxy and Nginx. What it's intended, what it was originally built to do, was live with your service and solve for those application networking concerns. So that when your application talks to another service, a database, a queue, or whatever, it goes through Envoy, and then Envoy applies and implements these pieces of functionality. If all of the services in your cluster start to deploy Envoy as a service proxy, you start to build the backbone of a communications mesh. All the traffic is flowing through a service proxy in this case, and you're getting consistent behavior around the resiliency aspects, the metrics collection and telemetry syndication aspects, and that is the definition of a service mesh. So that's how we get to service mesh. It's decentralized infrastructure that solves the application networking part of the problem. Okay? Solves things like security, like observability, policy enforcement, traffic control, and resilience. Most service mesh technologies try to solve these types of problems. Not all of them do. Some of them are subsets. But they aim typically to solve these types of problems, which were the problems that we saw in the previous slides about service discovery and load balancing and some of the resiliency aspects. Some open source service mesh technologies that solve this problem or aim to solve this problem are Istio. You may have heard of Istio. If you haven't, go buy my book. But Istio is an open source project from Google and IBM and Lyft. And more recently, more folks, the community has blown up. Red Hat's involved, Pivotal's there, Weaveworks, and other folks are there. Another project is called Console Connect from HashiCorp, which just kind of kicked off as a service mesh in the summer and is slowly building up its capabilities. So Istio is based on Envoy, and Console Connect is also based on Envoy. And then lastly, Linkerd, which has been around in various forms for a handful of years now, 3 or 4 years, but recently switched to a new implementation, and that's built on its own custom proxy that they built in the Rust language and Golang as a control plane. So basically what we're saying here is there is a kind of a layer, a set of layers here, where your deployment platform is your Kubernetes, or some distribution of Kubernetes or VMs, it doesn't matter. But that on top of that, you have your applications. But the implementation of those applications can be optimized for operability with the service mesh. And for developer efficiency reasons, you may opt to explore these new type of programming languages purposely built like Ballerina. Then you're probably going to ask yourself, or me afterward, well, isn't there overlap? There's definitely overlap because these programming languages solve for some of the app networking stuff. When do you use which? Right? If you don't take anything away from this talk, take at least these pieces of advice. That just because you use a service mesh does not mean you're offloading the responsibility of doing application networking to something else, even if it's decentralized like a service mesh. That is still the application developer's responsibility. Now, it might be implemented like a service mesh is implemented out of process. All right, so that's a bit of an optimization. And we said that was because we want to be able to operate our services at scale. So that's fine. But the configuration of those service mesh dimensions that developers care about, timeouts and retries, circuit breaking, and so on, you need to develop a workflow that allows developers to influence those values. Right? So using your CI/CD pipeline is a backbone, building up a developer workflow so that developers can influence those values. Now, that doesn't mean Service Mesh is going to solve every possible combination or permutation of these application networking problems. In that case, it's fine to prefer your language-specific implementation. Don't make that a habit, but rely on the Service Mesh until you can't, and then opt to use a language-specific implementation that's more fine-grained, maybe more tailored to what your application is doing. Now, in some of these Service Mesh implementations, the ability to influence the decision and the configuration of the mesh, both at configuration time, deployment time, and at runtime, exists. Some Service Mesh implementations, like the HashiCorp console, actually build an API for developers to write their own custom language extensions to be able to plug directly into the mesh. So that's even a trade-off there, or a hybrid approach there. On the other hand, even if the particular service mesh that you adopt enables you to do this, resist the urge to jam a bunch of application integration logic into the service mesh. Now, I know there will be certain circumstances where maybe it makes sense, but that becomes a very slippery slope. Keep things like call orchestration, aggregation of data, data consistency models, that kind of stuff. That belongs in your applications. Don't try to put that into some centralized infrastructure that then needs to be managed by another team. So I'm very quickly gonna show a demo. Before I do that, I'm gonna put my contact information back up here just so I can leave links and my contact information. Specifically, one thing that I'm trying to help the community do is to get more involved with open source technologies. All right, and sometimes that can seem daunting. Sometimes you say, wow, that project looks too complicated, and I don't know if they're going to accept my contributions. Even the smallest bit of contribution is useful to these open source communities. So reach out to me if you're interested in getting involved in any of the projects that I talked about here or any other ones and just looking for advice and thoughts, then absolutely reach out to me. I'd like to help people get more involved in open source. So the demo that I'm going to show is, well, I'm going to show one demo showing some of the features of Ballerina, and then I'm going to show, if I have time, what the resiliency aspects that you can get from the service mesh look like. So let's get going on that. So one thing I do want to show about Ballerina, I'll increase the font size here, is if we come here to the regular one. Oops. Is in the language, like I said, we can bootstrap and set up and create a new service very quickly using the constructs baked into the language. What's more interesting, or additionally interesting, is that the Ballerina's been built for deployment platforms like Docker-based deployment platforms or Kubernetes-based deployment platforms. So within the language, we can do things like does that zoom in? We can add config about our Docker builds. So I don't know if, I think it was a year ago when Brendan Burns showed off the metaparticle implementation that he created for co-locating some of the deployment configuration with the application code. This follows that similar principle. So using some of these annotations, we can, when we do a Ballerina build recommendation, the Docker one, we can see that it compiles it into a binary, but it also generates the Docker image for us. So I can do Docker, look at the last couple Docker images. We should, not Docker PS, image. There we go. We can see that this recommendation service was built 20 seconds ago just by putting that little annotation in there. Same thing can be done with Kubernetes. So by adding a service annotation to our listener, we can generate a Kubernetes service automatically, and we can also generate a deployment. Now the last thing, so I guess I can do that one super quick, but the last thing I want to show, Ballerina run, recommendations, Kubernetes, not run, build. If we look here under Kubernetes, recommendation, we can see it automatically generates the Kubernetes resource files for us. Now the last thing, which is pretty cool, is you can add, so if you're familiar with Istio at least, you can add an annotation to automatically generate Istio resources like virtual services or configurations for traffic to flow in through the gateway and co-locate this configuration with your applications. The last demo I'm going to show is switch clusters, is how we can use Istio regardless now of what language you might use to build your services to be more resilient and solve for those application networking concerns. So here we have customer, which calls preference, which calls recommendation. And what we're going to do some interesting things in between the call from preference to recommendation. So now you'll see, and you'll notice on the bottom, if it works, okay. Oh, shit. All right, well, you can see there's a live demo. Even though it's typing it for me, I can't get around sometimes network quirks. That's not gonna be sufficient for my demo here. So basically what I was gonna show is if you start to observe bad behavior in your system, either because I was going to inject bad behavior using Istio and then implement things like retries and timeouts and circuit breakers, you can do that with Istio's config, and those are the types of things that the developers need to influence. Those are the configurations that developers would need to influence, and that would work regardless of programming language. All right, I got 2 minutes left. I'll end there. Unfortunately, this particular part of the demo didn't work as well as I wanted. Are there any questions? I know it's kind of a large room, but are there any questions about the stuff that I covered? Yes, right here.
Maybe because it's the last one, but I'm really confused because we hear a message like we have Kubernetes, and then on top of Kubernetes we have service mesh like Istio, and then we will have Knative. Mm-hmm. So the developer can develop without thinking about application integration. You are telling us that this is not correct.
That is not correct. Application integration is going to be very important, regardless of what. So the Knative components allow you to basically simplify how you describe what an application is and deploy it. And you can do things like scale to 0. You can connect to events. You can build serverless function as a service on top of that. But if you're deploying a service, you're deploying applications on top of Knative that are not functions as a service, then you as an application developer have to be aware of integrating and talking with the various other services. All right, well, I appreciate all you coming. Enjoy the rest of the conference. Thank you.